Well, hi, folks. It's me again for what I hope to make a almost daily brief podcast concerning issues that I consider important and over which I think I have some insights that are not generally well known. My first podcast was about medical marijuana, and I'll probably do more of those in the future. My current subject that I'm going to discuss today is what happens to fossil fuels when they're burned and create CO2 and water vapor. Where does the CO2 go? Well, I'm sure we all by now understand that much of the CO2 becomes part of the CO2 in our atmosphere, having increased by many parts per million over the past few decades and over 100 parts per million over the past couple centuries, which is almost certainly the reason for significant climate change on this planet and what is called global warming. I liken CO2 to a thin cover. As you add more CO2, you add another cover to your bed at night and cuddle under the covers and get warmer as you add more covers. The planet has adapted to the amount of CO2 in the atmosphere over its 3.5-4 billion year history. And the biologic changes that have been associated with changes in CO2 have occurred gradually based on the gradual changes in the amount of CO2 in the atmosphere. When we burn wood or plant fibers, we are turning basically cellulose, which is long chains of carbon atoms, into CO2 and water. Well, that's where it started many, many millions of years ago. And it was trapped underground in many different ways: tectonic plate formation, mudslides, or tectonic plate movement, mudslides, volcanic action, such as that, and just basically plant life in the oceans dying, sinking to the bottom of the sea, and not decomposing there, but being buried over millions of years, and now being recovered in the form of petroleum products, natural gas, and possibly coal, though coal probably came about from the burial of actually land-based woody products. At any rate, the CO2, back when it was in the atmosphere before it was trapped by a plant that then died and was buried, was in the atmosphere at a higher concentration than it is today. Because of that, the surface of the planet was warmer, and as the CO2 was absorbed by plants, turned into plant material, and then buried, it was subtracted from the carbon or the CO2 in the atmosphere, lowering the CO2 in the atmosphere, and thus allowing the gradual cooling of the surface of the planet as more CO2 was extracted from the atmosphere and basically imprisoned in the form of fossil fuels. The planet got cooler because we basically took a cover off the bed. Well, when we burn the fossil fuels, we're adding that recover back to the bed in the form of CO2. Well, that sounds like it would be good for plants. Plants need CO2. They can't survive without it. The problem is that more CO2 is being produced than plants can absorb, and the number of plants around to absorb CO2 is diminished based on deforestation and similar projects initiated and propagated by humans. Another way CO2 gets out of the atmosphere, and perhaps even as an important way, is through the absorption of CO2, the dissolution of CO2 into water. If you have distilled water with pure CO2 above it, part of the CO2 will dissolve into the water, and the amount of CO2 above the water will decrease, and this will establish an equilibrium. Refer to Boyle's partial pressure of gases law. At any rate, it is estimated that over half, or about half, of the CO2 that we have released into the atmosphere from the burning of fossil fuels over the past 200 years or so is now dissolved in ocean water. It exists there in the form of carbonic acid. As the CO2 in the atmosphere goes up, the amount of CO2 absorbed in the oceans goes up. And if the amount of CO2 in the atmosphere goes down, the amount of CO2 in the oceans will also go down, seeking equilibrium with the partial pressure of CO2 above the ocean surface. So the reason this is important is that even if we completely stopped adding fossil carbon through the burning of fossil fuels and creating new CO2, the amount of CO2 in the atmosphere would only very, very gradually decrease, because as there was less CO2 in the atmosphere, there would be more CO2 released from the ocean surface into the atmosphere. So what this means is that the amount of global warming that has been created by our burning fossil fuels is on a collision course, or on a course to continue for some time, because it has a momentum, and we have no mechanism no real mechanism other than growing more trees to reduce the amount of CO2 in the atmosphere in a significant way. And as we reduce a little bit of it, then a little bit more of it is released from the ocean into the atmosphere. So what we're really trying to do, those of us that are trying to do anything about it, is to create an atmosphere, literally and figuratively, that our grandchildren and great-grandchildren can survive in. Even if we stop today producing CO2 by burning fossil fuels, we are in for a long, long period of continuing melting of the frozen water on land surfaces around the planet, mainly the Greenland ice cap, and of course the trapped water on the Antarctic continent. This will melt and run into the sea at a accelerating rate, as long as we accelerate the number of blankets we put on our bed by adding more CO2 to the atmosphere. The hope that exists for humanity is that we stop burning fossil fuels and start resorting to other renewable forms of energy that don't damage the environment. If we fail to do this, we will condemn future generations of humans to a life of misery and possibly to ultimate demise. So that's going to be the end of this little talk about global warming. It won't be the last one, but it'll be the one about the absorbed carbon dioxide in the oceans and water bodies of the planet. So I'll talk to you again sometime soon. Have a great day.